Okay, so we're going to move on in chapter 8. This will be our last section of chapter 8, and the last bit of calculus we'll do until the very end of the school year when we get into chapter 11. Okay, so this section here deals with derivatives of inverse functions. Um, let's take a look at how we take the derivative of an inverse function. So this says to suppose f is a one-to-one differentiable function, and its inverse function, f inverse, is also differentiable. Okay, and what we're going to do is we're going to use implicit differentiation to show that f inverse prime of x, so if we want to take the derivative of the inverse function, that's going to be equal to 1 over f prime of f inverse of x, provided that the denominator is not 0. Okay, so what we're going to do is actually like work through the derivation of this, just using a little bit of algebra and a little bit of implicit differentiation. Okay, so to start out with here, we are going to let y equal f inverse of x. And again, we're going to pretend like we don't know how to take the derivative of this function. Okay, so to get around not knowing how to take the derivative of this function, what we're going to do algebraically to start with is we're going to apply the function f to both sides of this equation. Okay, so when we do that, that gives us, when I take f of the left-hand side, that gives us f of y. And when we take f of the right-hand side, we get f of f inverse of x. Okay, so that makes f of y equal to, when we take the composition of a function and its inverse, on the right-hand side, f composed with f inverse of x. We said all the way back in chapter 1 in this class that the composition of a function and its inverse is equal to x. Okay, so the function and its inverse wind up canceling one another out, and that's just equivalent to x. And once we have this, now we have this written in a form where we can take the derivative with respect to x implicitly on both sides of this equation. Okay, so when we take the derivative with respect to x on the left-hand side, using chain rule, that's the derivative of the outer function f prime. We evaluate that at the inner function y, and then we multiply that by the derivative of the inner function, and the derivative of y is y prime. And that's going to be equal to the derivative with respect to x of x on the right-hand side, which is 1. Okay, and then we can isolate y prime by dividing both sides by f prime of y. Now, the last thing for me to do here is, like we said that y was equivalent to f inverse of x. So all I'm going to do is replace the y's in this equation with f inverse. So on the left-hand side, when I have y prime, I can write that as f inverse prime of x. And then on the right-hand side, we have 1 over f prime of y. Again, we're going to replace y with f inverse of x. So that is 1 over f prime of f inverse of x. Okay, so that is how we like use a little bit of algebra and some calculus with implicit differentiation to work through the derivation of um, the derivative of that inverse function. Okay, so we're just going to do 2 examples with this, and I'm pulling both of these examples from your guys's homework assignment, which is a worksheet. So I think I pulled questions numbers 1 and 10. And the directions here say given f of x, we are asked to find f inverse prime of a. Okay, so for number one, we are given f of x is the square root of negative 2x minus 4, and our a value is 2. Okay, so what this is asking us to find here is it's asking us to find f inverse prime of 2. And with the formula that we just, like the inverse derivative formula that we just calculated above, I know that that's going to be equal to 1 over f prime of f inverse of 2. Okay, so there are two things that I need to determine in order to calculate f inverse prime of 2. Okay, I need to know what the derivative of my function f is going to be, so I need to figure out what f prime is, and I also need to figure out f inverse at 2. So I'm going to figure out the inverse part first, and then we'll take the derivative, and then we'll plug that inverse value into our derivative. Okay, so again, this goes back to something that we talked about earlier in the year with inverse functions. So if we want to calculate f inverse of 2, okay, so f inverse of 2, that means that 2 is going to be the input for the inverse function. We don't know what the output is going to be. Okay, now I don't want to have to calculate what the inverse function is going to be. So I'm going to use the relationship here going from inverse to function, or function to inverse for that matter. All we have to do is switch the x and y coordinates of every single point, going from inverse to function or function to inverse. So on the graph of f, I am looking for the input that gives me an output of 2. Okay, so I am looking for the x value that gives me a y value of 2. So I can go then to my function f. I know that for the function f, the y coordinate of my point is 2. So I'm going to go ahead and plug that value in for y, and then I'm going to solve that equation for x. So 2 has to be equal to the square root of negative 2x minus 4. And then I'm going to go ahead and solve that equation there for x. So to do so, I'm going to square both sides of the equation. So we get 4 equal to negative 2x minus 4. I can then add 4 to both sides. So we get 8 equal to negative 2x, which means that x is going to be equal to negative 4. Okay, so I'm going to go ahead and plug this value here. Negative 4, that's going to be the x coordinate of f. And then when we switch the x and y coordinates going to f inverse, that is going to be the y coordinate of f inverse. So when we are being asked to calculate right here, f inverse of 2, f inverse of 2 we know is going to be negative 4. Okay, so this is going to wind up becoming 1 over f prime of negative 4. Okay, so all I have to do now is take the derivative of the function f and then plug negative 4 into that derivative. Okay, so my derivative f prime of x using chain rule, the derivative of the outer function rad x is 1/2 x to the negative 1/2 power. We're going to evaluate that at the inner function, negative 2x minus 4. And then we're going to multiply that by the derivative of the inner function, negative 2. Okay, so I can cancel that factor of 2 with this factor of 2, which is going to make f prime of x. Whenever I simplify it, we get negative 1 over rad negative 2x minus 4. And then I just have to evaluate that derivative. at -4. So we get -1 over, when I plug -4 in, we get 8 minus 4, which is -1 over rad 4, which is -1/2. And this becomes 1 over -1/2, and the reciprocal of -1/2 is -2. Okay, so that is what the inverse's derivative is at 2. Okay, so I want you guys to use the same approach to give number 10 a try. So for number 10, your function is f of x, which is equal to rad 2x plus 5. And then your a value here is 2. Okay, so I want you guys to try this one on your own. Pause the video to do that, and then whenever you're done, unpause the video and we'll discuss together. Okay, so for 10 here, this is asking us to find f inverse prime of 2, which, utilizing our inverse derivative formula, it's 1 over f prime of f inverse of 2. So the two things we have to figure out, number one is what f prime is, and number two, what f inverse of 2 is. So that's what I'm going to calculate first, f inverse of 2. So on the graph of f inverse, 2 is my input. We want to find the output. So on the graph of f, I am looking for the input that gives me an output of 2. Okay, so I'm going to plug 2 in for f of x, and I'm going to solve my equation here for x. So we get 2 equal to rad 2x plus 5. I can square both sides. We get 4 equal to 2x plus 5. When I subtract 5, we get -1 equal to 2x, which makes x equal to -1/2. Okay, so this becomes, the x coordinate is -1/2, which makes the y coordinate of f inverse -1/2. So when I'm being asked to find f inverse prime of 2, this is going to be 1 over f prime, and then we found f inverse of 2 to be -1/2. Okay, so all I need to do now is to take the derivative of my function f and then evaluate that at -1/2. Okay, so when I find f prime, this is 1/2 2x plus 5 to the -1/2 power, and then using chain rule, we multiply that by the derivative of the inner function, which is 2. We can cancel those factors of 2, which makes f prime of x equal to 1 over rad 2x plus 5. And then we want to evaluate that derivative at -1/2. So when I do that, we get 1 over, when I plug -1/2 in for x, we get -1 plus 5, which is 1 over rad 4, which is 1/2. Okay, so this becomes 1 over 1/2, and the reciprocal of 1/2 winds up being equal to 2. Okay, so that right there is how we take the derivative of an inverse function. And again, this will be the last bit of calculus we do until we get into chapter 11. So from here, we're going to transition into trig for the next 2 chapters, and then we'll do calculus with trig to wrap up the school year. So that's it. Hope you guys have a great rest of your day. Take care.